Let me give an example of operational semantics. So here are the two rules I showed for operational semantics in the slides. Let's consider a couple of cases. First, let's look at the number 1, right? So the e is a number n, therefore e can be evaluated to n. Rule clearly applies here. So in one step, we can see that the expression 1 evaluates to the number 1. Okay? That's pretty simple. Let's look at a more complicated case. So let's look at 1 plus 2 times 3. Okay? So we look at first we need the abstract syntax tree of this expression. So the abstract syntax tree for this expression is going to be plus is the root, 1 is its left child, multiply is its right child. Multiply has two children, 2 and 3. So we start evaluating this abstract syntax tree at the root. We can't evaluate plus yet because we don't know what the values of its children are. So we look at its first child, 1. We can, as we saw before, over here, evaluate the number 1 to its value 1. So I'm just going to underline this to show that that has been evaluated and we have its value. So now we'll look at the other child of plus here, which is this multiplication. We can't evaluate the multiplication yet because we don't have the values of its children. And we know that we can evaluate it because we don't have the values of its children, because that's what it says up here in the judgment. The two preconditions for the judgment are that the left-hand side expression has been evaluated to its numeric value n sub 1, and the right-hand side of the expression has been evaluated to its numeric value n sub 2. And you'll note that I'm using this rule up here, even though this says plus instead of multiply, because like I said in the slides, the rules are similar. We can come up with a rule for multiplication just by putting in multiplication signs instead of addition signs in this rule, like that. So before we can evaluate this multiplication, we need to know the value of its children. We can get the value of its first child, 2, by applying the other judgment, and 2 is a number, therefore its value is 2. Similarly for 3, 3 is a number, therefore its value is 3. So now that both of the children of this multiplication have been evaluated, we can evaluate the multiplication itself. The judgment rule up here says that if the left-hand side has been evaluated to a number, which it has, and the right-hand side has been evaluated to a number, which it has, then the value of e sub 1 times e sub 2 is n sub 1 times n sub 2. So we go ahead and multiply 2 times 3 to get the value 6. And once we have the value 6, then both of the children for this plus root vertex of the tree have been evaluated. And so we can apply the same rule. We have n sub 1 is 1, n sub 2 is 6, so the value of this plus vertex is 6 plus 1 is 7. And that's how operational semantics works.